Good evening. Um, Today we are going to be looking at relative atomic masses of some isotopic elements. Okay, like I've been taught in the class, an isotope is the existence or occurrence of atoms. Okay, atom of an element with different atomic mass and the same atomic number. For instance, chlorine can have chlorine. Okay, chlorine 35. I can have chlorine 37. So this is isotope of chlorine. So the atoms of chlorine are having two atomic masses or different atomic masses, but the same words, the same atomic number 1717. So the this thing is this the these isotopes, they behave differently physically, okay, but chemically they behave the same. Okay, the reason is because the difference in the atomic mass is the what is the work of the neutron, and you know that the neutron or atomic mass does not contribute to the chemical property of an element or atom. Okay, so it's the neutron that causes the difference here. So the atomic number, which is number of proton, which determines the chemical properties of an element, is still the same in two of them. So they will behave identically chemically, but differently physically. Okay, an element with relative atomic mass of 16 point what 2 contains two isotopes X16 with atomic number 98 with the relative abundance. So this particular isotope has the abundance of what of 90%, while the second isotope has relative abundance of 10% with Z as the atomic mass. Okay, as the mass. Okay, so we are asked to find the value of this Z here. The value of the Z, since this one is 16, what would be the value of this Z? Remember, I said that in an isotope, they have different atomic masses but the same atomic number. So they are asking us if this one is 16, what will now be this one, this mass here? Okay, so the formula we're going to use is relative atomic mass. Sorry, let me click this. Relative atomic mass, okay, is equal to percentage abundance, okay, times mass of A. So percentage abundance of A times mass of A, okay, plus percentage abundance of B times mass of B. So percentage abundance of, I'm taking this to be the first isotope to be A and the second isotope to be B. Okay, so everything all over what 100 because percentage is 100, right? All right, so from the question they gave us that 16.2 is equal to percentage. Okay, let's look at the percentage of the first one. The percentage is 90. Okay, so put it 90, okay, times by the mass. What's the mass given? 16, okay, plus, do we get it now? Percentage, which is this, times by the mass 16, okay. So let's move on. So percentage of B, what is percentage of B? They gave us 10. 10 is the percentage of B. So we have 10 multiplied by the mass. What's the mass here? The mass here is Z, okay, all over 100. Do we get that? Okay, so what we do in this sense now, we cross multiply. We do what? Cross multiply. So when this times this, we're going to be getting 1620. Okay, that's this times this. Okay, 100 times 16.2 give us 1620. That's 1620. Okay, is equal to 90 times 16. Okay, let's do that. So it's going to give us 180 equal to 10z. Okay, so we divide both sides by 10. So we're having that z is equal to 180 over 10, which is equal to, cancel this and this, we're having z is equal to 18. So it means that the atomic mass of this particular atom here is 18. So we're having 1440. So 90 times 16 is 1440 plus 10 times z is 10z. Okay, all okay, that's it. So what we do next, we collect like terms. So crossing this over, we'll be having this minus 1440 is equal to 10z. You know, when this crosses over, it becomes minus. Okay, let's look at this second example before we call it a day. All right, they said an element Z exists in two isotopic forms. Okay, in two isotopic forms, 39 and 40. Okay, in the ratio 3:2. So mark this ratio 3:2 respectively. So what is the relative atomic mass of this element? What we're going to do is to say sum of ratio is equal to 3 plus 2, which is 5. Okay, all right. So what do we do next? We say RAM is equal to um 3 over 5 times the mass of the first one. Okay, this is the first with this 3, okay, as the ratio, times 39, sorry, plus 2 over 5, that's 2 over the total ratio. 2 is for this guy here, okay, 2 is for this guy with 40, so times 40. Okay, remember they said this ratio respectively, so this 3 is for this one and this 2 is for the second isotope. Okay, so we are going to solve this times 39. Okay, to give us equal to 117. Okay, all over 5 plus 2 times this, of course, is 80 over 5. Okay, so which will give us 117, since they have the same denominator, 117 plus 80 all over 5. So let's add that together, plus 80. So we're getting RAM is equal to 197 all over 5. Getting 39.4. 39.4. Okay, so when you're given such, what you just do is to say sum of ratio. You find the sum of ratio of the isotopes. There can be three isotopes, just find them. Then to find the relative atomic mass of that particular element, you add you use the ratios all over the total ratio times by the what? By the mass of the element given, okay, plus the second one, just the same thing. Then you solve it like normal arithmetic. Okay, please share to your friends and also recommend us to your friends. Thank you and God bless you. See you next time.